Hello friends and a very good evening. So how are you all? As you guys know, we are dealing with the physical geography and we are almost done through the majority of it. But before we start, please give me a thumbs up if my audio is clear, if I am audible. If the sound quality is good, please give me a thumbs up in the comment section. And I'll tell you a brief about what we have done up until now. We have gone through very important theories of continental drift. We have done the seafloor spreading. We have done the convectional current. So today we are down to the plate tectonics or the plate tectonic theory. Before we begin, I need a thumbs up so that I know that audio is clear, the video is clear, everything is going good. This will be our topic for today, plate tectonics. Nishita, Punghuzali, thank you everybody. Hania, okay, so I figure out that Zainab, thank you everybody, thank you very much for the confirmation. So today we're going to start with plate tectonics. In the previous class, we did get a brief introduction about the plate tectonic theory, and today we will discuss it in detail, how the theory is very important to shape a lot of features on the earth. You will figure out where the mountains are and what are the features of the mountains, the regions of earthquakes and volcanoes. Today we'll know about a lot of these places. As I told you in the previous lecture, what the plate tectonic theory states that the earth is made up of a lot of plates, a large number of plates. There are major plates and the minor plates, and these plates interact with each other. If you look at this image, you will observe that these are all the plates, but they are not fixed. They are constantly in motion, and because of the motion, thank you. So because of the motion of the plates, you will find that they interact with each other. So the basic aim of plate tectonic theory is to help us understand how this interaction leads to the formation of various features on the earth. Okay, is that clear? Now we'll go to the plate tectonic theory in detail. Primarily speaking, the interaction between the plates or the boundaries is of three types. Now, have a keen look at my hands. If this hand and this hand is one plate, this hand represents one plate and this hand represents the other plate. If these two hands are coming towards each other, they are converging. They're converging. These are the hands that are coming towards each other. That type of a boundary is called the convergent plate boundary. If they are converging, that is a convergent plate boundary. Very simple. Converging is a convergent. If the plates are moving away from each other, going apart, then that type of a boundary is called divergent plate boundary. So convergent plate boundary coming towards each other, diverging from each other, that is a divergent plate boundary. Okay, and finally you will find one more type of boundary, that is transform boundary. In this kind of boundary, you will figure out that the plates are not coming towards each other or going away from each other, but they'll go parallel to each other, they will pass each other. That type of a boundary is called the transform plate boundary. So these are the three types of boundaries that are there in the plate tectonics, and now we'll go to each and every plate boundary in detail. First, starting with the convergent plate boundary. In the convergent plate boundary, as I told you, the plates will collide or come towards each other. Okay, if you have any question, you can ask me in the comments. Okay, I'm seeing your comments as well. So when the plates collide with each other, when the plates come towards each other, that is the convergent plate boundary. There are a few things that you need to know before we go into the details of this. In this, the plate with the relatively lighter material will override. If a plate is lighter or less denser as compared to the other plate, then the plate will not subduct, but it will go over the heavier one, and the heavier plate will subduct. That we will look in detail how the plates will subduct in different cases, and the denser plate will subduct. Now, before we begin, we have to understand that there are multiple types of converging plate boundaries. First, see, as you know, look at this diagram first. Before we begin, I want to look you at this diagram. If you look at this diagram, you will see this is a North American plate. Okay, just observe the pattern. This is the North American plate, and then you will find one other plate, that is the Pacific plate. This yellow one is the Pacific plate, and this one is the North American plate. So the name suggests that this has to do something with the land part, the continent part, and this is something to do with the oceanic part. So primarily we have two types of plates. One is the oceanic plate, whose majority of the part is an ocean, and the other is the continental plate. So two types of plates are there. One is the continental plate and other one is the oceanic plate. Now we have to understand and analyze how the collision or the convergence of these two plates will lead to different landforms on the earth. So what two plates we have? One is continental and other is oceanic. So what type of these collisions are possible? How many types of convergence can be there? Let's take each and every collision one by one. First, let us assume that the two converging plates, one is a continental plate and the other one is an oceanic plate. So the first type of collision that is possible. Hello C2, hello. So the first type of collision that we're going to figure out here is, this is the continental plate and the second one will be oceanic plate. This one is the oceanic plate. Okay, this is the first type of collision or the convergence, continental and the oceanic. This is the first possibility. Then we go to the second possibility. This is first possibility. If the color is visible properly, if the yellow color is visible, do let me know. If there is any problem, you can tell me. If the colors are not properly visible, if there is any issue, just let me know, so that I can adjust accordingly. This is the first type of convergence, the continental and the oceanic. Then the second type we can have is ocean and ocean. Both are ocean. This is the second type of possibility. Both the plates are oceanic. That is also a possibility. And the third one is that continent and continent. That is the third type of possibility that is there. Okay, this is the third possibility. Both the plates are continental. So three types of possibilities are there. First one, visible. Thank you for the confirmation. Everything is clear, sir. Thank you very much. First one, second one, and third one. Continent, ocean. This is very important. No, continent, ocean, ocean, and continent. These are the three types of converging plates that are there. We'll take each and every case individually so that you understand each case, starting with the convergence of ocean and the continent. Okay, first, if this is a continental plate and then we have another plate that is oceanic plate. Okay, this is the oceanic plate. They are moving towards each other. Look at the direction of the arrows as well. They are converging. They are moving towards each other because of the asthenospheric activities that are going there. You know that in asthenosphere we have the magma that is continuously moving, and this is because of the movement of the magma that the plates will start to converge. Look at the direction of the arrows. This is how, because of the asthenosphere, the arrows, these arrows are showing the directions. Because of the asthenospheric activities or the convection currents, the plates will eventually converge. Now, what will the conversion lead to? That is very important. You have to know that. So these are the two plates that you have looked at. Now look at the conversion, how the conversion is going to be. You need to know which plates are dense and which are not, because we have already gone through this. So you know the oceanic plate is much denser. Oceanic crust is much denser as compared to continental crust. So as I told you, the less denser will not subside, but the more denser plate is going to subside here. Okay, so the more denser plate is going to subside here. So when we look at this, see, this is the continental plate again, and we have another plate that is the oceanic plate. This is the oceanic plate. This is the oceanic plate, this is the continental plate. So the plate that is going to subduct is the continent or oceanic plate, not the continental plate, because the continental plate is less denser and it will go over the oceanic plate because of the activity of the magma that is going on in the asthenosphere. Now this, when it will come towards this, then this is how the plate will go under this. It will subduct. If you look at these diagrams, you will figure out that the plate is subducting, it's going, and this plate will go eventually here. Now this plate is subducting, and observe it properly, because you will realize that this is not the case every time. The plate is not only going under the continental plate, but it is also going into the asthenosphere. Okay, it is also going into the asthenosphere, and when it goes into the asthenosphere, it will melt there because of the high temperature that is present there. Hi sir, hello Irshad, how are you? So this is how the things will work. Because the plate is going into the asthenosphere, it will eventually melt because of a very high temperature. The plate is going to eventually melt. Now, one thing that is very important here is that once it will melt, what is going to happen? Imagine this place that is having the constant convection currents, but when the plate will melt, the pressure in this region is going to increase because of the excess amount of magma that will be generated because of the melting of the oceanic plate. When it will melt, the first thing that is going to go is the pressure will increase. On the top of the land, what you will observe is that there will be mountain formation. Why will there be mountain formation? Because of the sediments that are present, because of the conversion, the fold mountains, or the mountains that will form here is the fold mountains. Now, let's first look at how the mountain formation will be. Look at this separate diagram. This is the continental part, and here we have the oceanic part. There will be the sediments that will be present here. What kind of sediments? Because on the continental margins we will find sediments. Because of the coming of the rivers and other things, they will bring along with them the sediments. This feature is very common where the continent will meet with the water body or the ocean. Because of all the sediments, these sediments will get accumulated here, and when the collision will go on, just take an example of this. When the collision will be there, there will be a thrust that will just fold this, and these sediments will result in the mountain building. Because once these will fold, just look at the hands, these will go like this, they will fold, and there will be the formation of mountains. There will be a folding, and with the presence of these sediments, they will eventually get uplifted, and this will lead to the formation of mountains. Okay, so what we'll get here is the formation of mountains. These mountains that are resultant of the folding of the boundaries and the sediments are called the fold mountains. These are called the fold mountains. These are the fold mountains. So for the fold mountains to form, the first thing that is important is the convergence of the continental and the oceanic plate. Clear? This is number one. The plate has to collide with someone. It has to go for the compression. That will lead to the formation of the fold mountains. So is it clear how the fold mountains are formed? You can tell me in the comments if you have any question how the mountains were formed. Just look at these two hands. When they will exert force on each other, plus there is something already present on the continental margins, the sediments. These sediments are named as geosynclines. The sediments that are present on the margins are called as geosyncline. Geosyncline. Okay. Geosynclines are the sediments that are present there, and this will lead to the formation of the fold mountains. Very important thing, how the fold mountains are formed. Now, one more important thing that we're discussing is what is going on inside of the earth. Because the oceanic plate went to the depths of the asthenosphere, Nishita, okay, thank you. When it went to the depths, it resulted in the melting of the oceanic plates. Because of the melting, the pressure increased a lot, and when the pressure increased, it will come out. Look at this red arrow that I'm going to draw. The pressure release will result in the coming out of this. And when the magma will come out, what is it called? The magma that comes out, it is called the volcano, lava. That will result in the formation of volcanoes. This is the place where you will find volcanoes as well. So the formation of volcanoes will also result because of this increased pressure in this region. Is it clear how the pressure increase will result in the formation of volcanoes? So volcano, what are the features that we have figured out up until now? Rider Gaming, I am watching your informative video from Pakistan. Thank you, thank you. Okay, thank you very much. Thank you, Zainab. That's right. Okay, so this is how the lava will be formed because of the increase in pressure. So two important things that you need to know here that are there. First, you can take these 2 points down. You can use a star mark and take these 2 points because these are very important. If everything is clear, then I'll wipe it and I'll tell you what you should write. First, there will be fold mountains, number one. Number two, there will be volcanoes. Two important things, fold mountains and volcanoes. Another important thing that you will find here is earthquakes. Why earthquakes? Because of the convergence or the disturbances that take place inside of the earth, you will find the presence of earthquakes as well. So these are the things that you will usually find that are associated with the ocean continent convergence. That is about the ocean continent convergence. Plates converging will lead to fold mountains, number one, very important. Number two, volcanoes, and number three, earthquakes. You will find all these things there. There is one more thing that you will find here is, look at this area. You will find a bit of a gap here where the plates are converging. This kind of a thing will be there. What is this called? It's called a trench. So you will find trenches as well. So these are the four important things that you will find here. This can easily be a question for you. What are the features that are associated with the continent ocean convergence? Then you will have to answer it like this: fold mountains, volcanoes, earthquakes, and trenches. These are associated, and you can easily explain how these are formed. Now, this is what I was telling you. Look at this image properly. This is the image that we're drawing. Now, if you look at this image here, this is the oceanic crust that is subducting under the continental crust. This is the continental crust. Because of the subduction here, you will see it is gone into the asthenosphere. The red color is the asthenosphere that I already mentioned. Because it is gone in the asthenosphere, it melts here, and the magma has started to come out on the land. So that results in the volcanoes. This is how the volcanoes are there. On top of the earth, you will see the fold mountains are formed because of the convergence, and here you will find the trench as well, and earthquakes are present because of the disturbances that take place inside of the earth. Okay, are we done with this? If you have anything, subduction of ocean continent plate, you will find geosynclines deposited. Geosynclines, as I already told you what geosynclines are, I hope you know it. And then you have earthquakes, volcanoes, fold mountains, trenches, and you have examples of Rockies and Andes. These are the mountains that are found in the North and the South America. This is just an example how these things work. This is an example of Andes mountain. If you look at this range, this is the Andes mountain range. It is the longest mountain range in the world as well. It is present in South America, and because of the convergence of two plates, you will find the South American plate on this side, and you will have other plate. You can name me, tell me in the comments what's the name of the plate. It is a minor plate. Just for your hint, it is a minor plate that is present here. It's not a major plate. You know the difference between the minor and the major plate? Just tell me the name of this plate in the comments. What is the name? This is the South American plate. Name this. And now let's go to the second type of conversion, that is ocean-ocean conversion, where both the plates are oceanic plates. Okay. Now, when we go to the ocean-ocean conversion, what all things you need to know? There will not be geosynclines. Nazca plate, correct. That's great. That's right. Nazca plate is the name of the plate. That's the minor plate. So, when you go into the ocean-ocean conversion, you will find that there is no geosyncline present. Clear? When there is no geosyncline present, what is the obvious thing that is not going to be present there? As I already mentioned in the previous conversion on the collision, that how geosyncline helped in the formation of a specific feature. Tell me what is the feature that will not be here because of the absence of geosyncline. When we talk of the ocean-ocean collision, you will find that both the plates are considered dense, but there is going to be some sort of difference in the densities. So again, the less dense plate will not subduct and the more dense plate will subduct. Again, the thing will be same when the plates will subduct. If one plate is subducting, it will go into the asthenosphere again. That will result in the formation of the magmas on such places. If you look at this diagram, again, you know that this place in the underground part, we have the asthenosphere that is present here. So this is going to melt again, and this will result in the magma. So there will be lava or volcano. Nishita Nair, sir, where are you from? I'm from Jammu and Kashmir. Okay. So this part will result, the melting of this part of this will result in the formation of volcanoes. So one thing for sure is that volcanoes will be there. Okay. So volcanoes will be there. Presence of volcanoes is there. As I mentioned, there is something that will not be there. Tell me in the comments what is that. Volcanoes will be there. Number two, will the earthquakes be there? Yes. Why? Because of the disturbances in the plates, you will find the earthquakes as well. Earthquakes will also be there. Trenches will also be there. If you look at this gap here, the trenches will also be there. The trenches will also be there. Now, because of the absence of geosynclines, the fold mountains will not be there. The mountains will be there. Don't get confused. Fold, I'm talking about the fold mountains. There is a difference between the two. Okay, tsunami. Well, tsunami obviously because of the underground earthquakes, that's a good answer. But right now we're talking about the fold mountains. Because of the absence of geosyncline, you will not find the specific fold mountains as we figured it out here. Look at this image. You found out that there were fold mountains, but in this case, you will not find the fold mountains because of the absence of. How in the world can someone be so cute? Thank you. Thank you very much. This is the oceanic plate. This is another oceanic plate. When they are converging, when they are colliding with each other, you will figure out that there is the melting of one plate that is subducted, that has gone under, which has resulted in magma. This is the magma that is there. Now, because of the magma, what happens is it will slowly come out over the period of years. There will be the formation of island arcs. The island arcs will form because of the magma that is being released over the period of the history. This will result in the formation of island arcs. As in Japan and other places, you will find that in these places, these are the island arcs that are formed there. And it's not something else. It is because of the volcanic eruption. But remember, there are no fold mountains. It's very evident from the diagram that there are no fold mountains. Love from Pakistan. Thank you. And thank you very much. And then you will find island arcs present here. Is it clear? Everything good? If you have any question, you can ask me in the comments. This is the features that are associated with the ocean convergence. So what you find here is the volcano, correct? Island arcs, trenches, and earthquakes. What you will not find here is. Oh, thank you. You can join this. This is a series going on and you can watch all the classes, and thank you very much again. So this is very important here. If you look at this, you will find there are no fold mountains. So when you appear in the examination, it's a very good question. There's a good possibility that you might be asked, is there a possibility of fold mountains? Is there? No. In this case, the fold mountains cannot be there. Is it clear? Again, the same thing, subduction of the more dense plate, volcanic islands, you will find. What is the feature that is associated with the ocean convergence? It is the volcanic islands. Then you have volcano erupts on the plate that is not subducted. This is very important point. I missed it here. Just look at this diagram once. If you look at the volcano that is erupted here, I'll draw it with a different pen that you differentiate. This is one plate. This is the plate that is subducted already. Then we have second plate on this part. How, if there's a question, how will you figure out which plate is subducting? If there's a question, you can tell me in the comments, how will you figure out which plate is subducting and which plate is not subducting? Because in ocean continent convergence, you can easily tell that in the ocean continent convergence, you can easily tell that there is a proper subduction of the oceanic plate. But in the ocean convergence, how will you figure out which plate is subducting? How can you say that? Because you cannot go into the earth. It's not possible to go deep down inside of the earth. So how will you predict that this is going there? Because you have to find out where the volcanoes are. Wherever you find the volcanic eruptions, that plate is not subducting. If you look at this image, you will find the volcanoes to be here and the plate that is subducting is this one. So the volcano will be always on the lighter plate. This is a very good question. The volcanoes will be on the less dense plate, but the Correct. Formation of islands or the volcanic eruption. That's right. Good answer. So the volcanoes will only form on the less dense plates, and this is how we can figure out which plate is subducting and which plate is not. So there will not be fold mountains. Very important. You will have volcanoes, earthquakes, and trench formation as well, but not the fold mountains. And there is an example, that is Japan. This is how the things will be. Then going to our last type of, this is the trench. This is an example of trench, diagram of trench. Here you find the trenches. This is how the trenches will be. Then they will merge together. This is not a trench. Don't get confused if you get a diagram like this. Don't get confused because of these things, because this is the mid-oceanic ridge where this is going away from each other and not coming towards each other. And this is a proper trench. There's a difference between the ridge and the trench. Ridge is formed in the middle somewhere, and the trench is formed where the plates will collide. This is how the things will be. Okay, then we'll go to the continent-continent conversion. As you already learned about the ocean, continent, ocean. Now we'll go to the continent-continent. In the continent-continent convergence, you will find out one thing, because the continental plates are not that dense. As I already told you, the continent plates are less dense because of the presence of SiAl. Okay, because of the presence of this, the continent plates are less dense. That is why when the plates will converge with each other, thank you very much, because when the plates will converge with each other, you will figure that because of this, the plate will go, but it will not go into the asthenosphere. Look at this diagram. It is going up to this depth, but it's not going into the asthenosphere. Question for you guys, just tell me in the comments, if the plate is not subducting up to the asthenosphere, correct, if the plate is not subducting up to the asthenosphere, which feature will be missing in this type of convergence? Tell me quickly in the comments which type of the feature will be missing. First, when the plates will collide with each other, there will be proper earthquakes. Because of the disturbances in the plates, there will be earthquakes. Silicon and aluminium, right? Because there will be earthquakes. After that, you will find the fold mountains. The fold mountains will also be there because there will be geosyncline on the plate boundaries, and the plates will collide from both the sides. There will be more geosyncline as compared to the first collision. So the fold mountains here will be very high. Their height will be very high as compared to the first case. As in case of Himalayas, the Himalayas have got a very huge height. They are very high as compared to the Andes or Rockies and other convergence. Is it clear? This is the third type of convergence. So you will find the fold mountains here. You will find earthquakes, but you will not find trenches and volcanoes. There will be no volcanoes, there will be no trenches. Is it clear? So two things that are not here, no trenches, no volcanoes. That is about the convergence of continent-continent. So the denser plate will subduct again, the gigantic fold mountains will be there. As I told you, the reason I also gave you why there will be. And finally, you will find Himalayas is an example. Earthquakes will also be there. So these are some of the types of convergence that are taking place there. Now let's make a summary table of it. I want you to just be with me in the comments so that this summary table will be important for you if you are about to appear in an exam, because you just have to go through this and you will get all the lecture easily. But I want your replies as well. Okay, you answer me in the comments. Hello Irfan, hello. So volcanoes, earthquakes, then you have fold mountains, and finally you have trenches. You tell me, this is a summary table for you. Just tell me quickly whichever physical properties. In the continent-ocean convergence, is there a possibility of volcanoes? Yes. In ocean, yes. In continent, no. Why? Because the plate is not subducting into the asthenosphere. It doesn't go up to the depths of asthenosphere. That is why there will not be volcanoes in the continent-continent convergence. Clear? After this, earthquakes, what do you think? Because of the plate disturbances, the earthquakes will be everywhere. So earthquakes will be everywhere because of the plate disturbances. Talking of the fold mountains, yes, for continent ocean because of the presence of Correct. Because of the presence of the geosyncline, you will find it, but the fold mountains will not be here in case of ocean conversion because of the absence of these things. And then finally, you will find it in continent as well. Trenches, as you know, they will be present in this, but not in case of continent. So this is a summary table. If you need it for your revision, this is for rapid revision. I'll just move away from the screen so that you can take a screenshot if you want. This is very important for your revision purposes. And if you have any question, you can ask. Okay. Now we come to the divergent plate boundaries. We are done with conversion. What is divergent plate boundary? When the plates will go away from each other. Convergence was when the plates were coming to each other. Now that part is done. The plates will start to move away from each other. Again, because of the movement of magma in the asthenosphere. Because of the movement of magma in the asthenosphere, the plates will move away from each other. So these are also called conservative plate boundaries. Why are these called conservative plate boundaries? Because new crust is being developed. In case of the case of the convergence plate boundaries, the crust was getting destroyed. Whenever the plates would meet, the crust would get destroyed. That is why they were called the destructive plate boundaries. But this is called the conservative plate boundaries. Constructive, it's constructive plate boundaries, because not the conservative. It's the constructive plate boundaries because of the presence of the new crust that is being developed continuously. Then you have formation of mid-oceanic ridges and block mountains that are associated with the divergent plate boundaries. Please correct it here. It's the constructive plate boundary, not the conservative. Okay. Any questions up until now? Please ask me. This is how this will work, and you will find volcanoes, earthquakes associated with these features as well. Why? Because when the plates will start to move away from each other, if you go back into the sea floor spreading, you saw the plates were starting to diverge. They were moving away. That resulted in the eruption of volcano that came to the ocean bottom, and that resulted in the sea floor spreading and the formation of new crust. No, I told you there is a formation of new crust every now and then. That is why the constructive plate boundary. These are some of the features that are associated with this. If you look at these arrows, you will see how the divergence takes place. There is magma that is coming, because when the plates moves away from each other, the plate movement will result in the eruption of volcano from the bottom that will come to the surface. Okay, this will be that. And then there is also the formation of block mountains in case of continents that we're going to discuss in detail. First, we'll discuss about the ocean divergence, how the ocean divergence work. This is an image of the mid-oceanic ridge or the Atlantic Ocean. If you look at this part, this is called the mid-Atlantic ridge. Mid-Atlantic ridge lies in the Atlantic Ocean, and on one side you will find the Europe, and on other side there is South America, North America. This is Africa, and this is Europe. Clear? Here the divergence takes place. Because of the divergence, you will figure out continuous magma is coming to the ocean bases that results in the spreading of the ocean crust and eventually formation of new crust near the rift, and away you find the old crust. This is what we learned in the seafloor spreading. This is how the process works. Initially, the two plates were together. These two plates were together. Don't go towards the arrows, this is not a direction. The two plates were together. Then the magma, if you look at this red color arrow, the magma started to thin the crust, and the plates that were like this, because of the pressure, the magma, the plates start to move and started to break. This resulted in the rift valley here. You will see a bit of a rift formed. The formation of the rift valley. When the rift valley is formed because of the continuous movement of the magma, divergence of the magma in the asthenosphere, the plates will continue to move away from each other. The plates, because of the continuous movement away from each other, will result in the water coming from the surrounding areas in between. That will result in the formation of rift valleys. Sea water will come and result in the formation of some water body, and over the period of time you will find that there is a total replacement of the landmass that is gone away from this place, and this resulted in the formation of the sea or ocean. As you can see here, because of the movement of this continent and this continent to these places, this is a complete sea that is called as Atlantic Ocean. So this is about the Atlantic Ocean, how the divergence works here. Then we will learn about the mountain formation as well. If you have any confusion up until now, any question, please ask me. Any confusion, any question? Okay, so shall we move? Then there is a formation of block mountains. We have Zainab, that's right. It is happening in the Horn of Africa. There's a part of Africa that is breaking. That's correct. Just that if you are asked about it, then I'll tell you. Because the African continent is breaking in two parts because of the divergence. You will see the Rift Valley lakes are there. That we're going to target this Saturday in the class when we talk about the mapping of Africa. We'll talk about the Rift Valley lakes as well. That's correct. Good. Now this is how the rifts form. First the rocks will be like this, then they will start to break. They would have been together one time, then they started to break and they were gone away, and this resulted in the formation of, this is a mountain, this is a mountain, this is a mountain, and in between you will find a valley, a rift valley. This will be your, it's called a horst, and this is called the graben. The valley is called the graben. This is the term. Okay, horsts and gravens are the resultant of divergence. If a question comes, what leads to the formation of horsts and graben? The answer is the divergence. And the example, Vindhyas in India. You can answer that. The formation of Red Sea. These are all the examples of how the rifting has worked over the period of geological time scale. Is everything done with the divergence? Then there is a difference. If you ask me about what is the difference between a fold mountain and a block mountain. If you look at this image, this is a block mountain. See, it has very steep sides. This is a block mountain, very steep sides. Because of the divergence, it breaks like this. This results in a steep sided mountain. That is why this is called the block mountain. It's like a block. But if you look at this image, this is a proper fold mountain, the Himalayas. They are not that steep. They will be like this. This is a proper difference between the Himalayas and the block mountains. Okay. Now going towards the last part of the lecture, that is the transform boundaries. Transform boundaries where there is no convergence, no divergence, there is only one thing, that is going past each other, parallel to each other. Movement is parallel to each other. So will there be any kind of subduction or something? Because the plates are not colliding at all, so there cannot be subduction. Will there be any kind of any other feature that is like a fold mountain formation? What do you think? Because there is no convergence, how can the fold mountains be there? It's not possible. So there will be no fold mountains. No fold mountains possible. Okay. But the earthquakes will be there. Because of the disturbances in the plates, the earthquakes will be there. Thank you. The earthquakes will be present in such kind of activities as well. Thank you, Shambhavi. Now, this is also called as conservative plate boundary. Why is it called the conservative plate boundary? Because neither there is a formation of crust. Thank you, Malhar Vizi. Because of the formation, there is neither formation of the crust, nor subduction, nor destruction. So it's called a conservative plate boundary. The crust is neither created nor destroyed. The plates will slip past each other. This is very simple. The plates will slip past each other. But where do you find these kinds of activities? Where will you find such things? This is an example that you need to look very keenly. If you look at, just for example, I'm giving you an example. If you look at the fault formed or anything, divergence, convergence, does it go along a straight line? If you look at the Atlantic Ocean here, you will figure out that it is not in a straight line. It is a bit of S shape. Here, look, is it a straight line? Is the rift developing in this manner? No, it is going in a zigzag manner like this. So it is not in a straight line. This is a very important thing in order to understand the rift, in order to understand the transform boundaries. Yes, Zainab, that's right. Only earthquakes will be present. Now, see, this is a proper rifting here. The red line indicates the divergence. Look at these arrows. This indicates the divergence here. This is also divergence here. But what you find in between is a gap. These are not continuous. The divergence is taking place here and the divergence is taking place here. But there is a gap because this is not in a straight line. This gap is filled by a different type of a rift. Is it visible? This is filled because see, this is here and it is here. So this gap is filled by a different kind of a rift called the transform rift. This is a transform fault zone. This is how the transform faults will usually work. Not every time, but most of the times, if you look at the mid-Atlantic ridge as well, if you carefully look at the diagram, you will find out that these kinds of activities are there as well. These are always perpendicular to this kind of divergence, to this kind of plate tectonic activity. These will always be perpendicular. Is it perpendicular? See, this is going on like this, then you will find it like this. So this will be perpendicular. The diagram is in such a way that it doesn't look like perpendicular, but it is perpendicular to this kind of rifting. So transform faults will be perpendicular to divergence kind of rifting. Is it clear? This is how the three types of transform boundaries will work. This is a very famous rift of the San Andreas in USA, where very powerful earthquakes are there. This is in USA. Okay, this is an example in San Andreas. Now we come to the last part of the topic. This is the ring of fire. Why is it called the ring of fire? Because there are a lot of volcanic activities that take place in this region. Okay, if you have any questions, because we are going to end it now, you can ask me in the comments. By the time you can look at this, this is a very interesting thing of our lecture. We're going to conclude our lecture here about the ring of fire. You know, this plate is the Pacific plate in the center. This is the Pacific plate. On one side, you will find other plates, Juan de Fuca plate, North American plate, South American. This is the Nazca plate that Zainab answered. This is the Nazca plate that I asked here. This is the answer. Then you have other plates here. You have Eurasian plate and Philippines plate. These are the plates that are present in this region. Now, as you know, the plates will not be fixed at one place. The plates will be in motion. Because the Atlantic plate is moving in this direction, because of the movement in this direction, here it is going to cause the convergence. You will find normally in this region, the red area, there is the convergence. In red areas, you will find convergence. Because of convergence, what is going to happen? This is the ocean-ocean convergence. As I told you, in ocean-ocean convergence, there will be earthquakes, there will be volcanoes, but no fold mountains. If you look at this region, it has a lot of earthquakes and volcanoes. If you know about Japan and Philippines, every now and then there is a volcano, every now and then there is an earthquake. So this region is prone for earthquakes and volcanoes. All this region, except for the formation of fold mountains, because there is no geosyncline. Okay, this region is for the earthquakes. Now, have a proper look at it. There you will find very important things as well. There will be trenches as well. Because of the convergence of the oceanic plates, there will be trenches as well. There is a famous trench here. Just tell me in the comments what is the name of the trench. Active volcanoes. Nishita, that's right. Correct. Here will be a very important trench present at this place. Just tell me what is the name of the trench. Okay, so on this side, on the red areas, you will find the convergence. Now, if you go towards this side, because the plate is moving away from here, we will lead to formation of divergent plate boundaries. Clear? There will be divergent plate boundaries on this side of the ring of fire or the Nazca plate and the Pacific. You will find the divergence. Look at the color yellow. If it is visible, if it's not, then there is a yellow color in between. You will find because of the divergence, because it's moving away from this. There will be divergence. So this feature will include the convergence and the divergence. Now, because I already told you, in these places where the divergence is going on, you will find the transform boundaries as well. So the dark yellow color that is present in these places shows the transform boundaries, which is perpendicular to the divergent plate. Okay, Mariana Trench. Right. Zainab, that's right. Yes, Shambhavi, correct. That's right. Good. Looks like you're in touch. Very good. Thumbs up. Okay. So this is about the... On this side, you will mostly find the converging plates, and on this side, you will find the diverging and the transform boundaries as well. Then a question, why is this red again? Is there some conversion going on? Yes, I told you there's a Nazca plate and the South American plate that are converging. Formation of Andes was the example. That is about the ring of fire, how, on which side you can do the convergence, divergence, transform boundaries, everything. The deepest trench, that's right. It is the deepest trench. It's the deepest place. That's very good. So if you have any question, please ask me in the comments. We are done with the lecture. This was about the plate tectonics, how the formation of mountains is there, how there is active volcanoes. Now you will be having an idea where we'll find the volcanoes, where we'll find the earthquakes. So it will be easy for us to set up the seismograph accordingly. There is a question asked when we're studying the when I was teaching the earthquakes. Somebody asked me in the comments that how do we place the seismographs in the world? Where do we place it? Now you will get the answer where we have to place these seismographs. Obviously around these places that are more prone to earthquakes and volcanoes. Thank you. Thank you very much. Any question? Anything? You can ask me. That is all about today's topic. I hope you understood. I'll wait for 30 seconds to take your questions. If you have any question. Thank you. Thank you. I'll take 30 seconds. If you have any question, anything regarding today's topic, please ask me in the comments. I'll be happy to answer. Anything. So we're done with plate tectonics. We are done with other things like continental drift, seafloor spreading, convectional currents. Okay, Zainab, thank you very much. It was a great session. All clear, sir. Thank you. Thank you, Nishita. I think that's all for today. So I'll be ending the session now. Thanks for cooperating. Thank you for being here, being active in the chat. See you in the next class on Saturday. Be there for the mapping session. We'll be doing mapping for this African continent. That's all for me today. See you next time. Bye-bye.